So as I regraded all your tests and I put all your homeworks in D2L. So your D2L is pretty up to date. So if I make any mistakes on the grading there, you just need to just send me an email and telling me, hey, David, online homework 5.1 should be 100%, not 10. How do you calculate your overall grade? In order for you to calculate your overall grade in your D2L, is you have to click on the calculator icon. And once you click on the calculator icon, they will show you all the, all the points. And then at the end there is like something over 65, or I think it's something over 65 or 7, something like that. That is your overall grade. So you have to take out your calculator and do like 50 over 65 or whatever you get there. That, then change to percent. No, this proportion. I think you guys know how to do proportion here now. So change that proportion to percent, just multiply by 100. And that is your overall grade in this case. Do you guys got what I'm trying to tell you about your grade in D2L? So please check D2L and see if I make any mistake or not. Okay, that's very, very important. So we're going to start the class today with homework questions on 7.1. So that's one section due tonight. Anyone have any questions on 7.1 homework? Anyone have any questions on 7.1? You guys are really quiet. All right, no questions. So we will start 7.2 today and 8.1 because you got 2 sections of homework due tonight, which will be 7.2 and 8.1. Not tonight, next Wednesday, sorry. So next Wednesday, you got 2 homework, 7.2 and 8.1. So I'm going to show it to you how we do 7.2. Again, what is the difference between 7.1 and 7.2 is 7.1 is talking about proportion or percentage. So when you guys read the questions, especially in the test, make sure you read the question very carefully. It's because 7.1 is doing what we call as confidence interval for proportion or for the percentage. They are the same. 7.2 is also doing what we call as confidence interval, but is all about mean. So they're asking for confidence interval is mean. Okay, so that's the reason why a lot of students do not do well in the finals. It's because they don't read the question carefully or they doesn't know what to do. So these are, when I highlight something like this, that's the keyword that you're looking for here. Okay, so make sure I really strongly suggest in my test to print out the test so at least you can draw or underline or highlight it, so you know that is the keywords that that you're looking for. So for population mean, the best point estimate is your sample mean x bar. So if you remember last time in your proportion in 7.1, what is the best point estimate for the population proportion is your sample proportion p hat. So that is 7.1. So you figure out what is p hat here. But for mean, it's very easy. It's the sample mean. So the sample mean is the best point estimate for the population mean now. Now, remember last time when we talked about the election, it's like 48% plus minus 3%. We don't use percent anymore because this is mean. So for mean, we will mostly talk about quantitative variable like height, weight, test score. So we will talk about that now. So what happened here is, example that we will use in this case is like, let's say your test score. So your first test, your midterm test, is gonna be 72 plus minus. Why this thing doesn't pop up? Okay, something wrong here. Sorry, I need to reopen it. It's not coming up here. Sorry, my PDF is something wrong. Something wrong with my PDF. It's not coming up. Okay. Okay. Hopefully this will come up. So so when we talk about mean, we will talk about quantitative variables like test score and height and so on. I spelled it right. Yep, like test score, height, temperature. And so we don't use the plus minus that you guys, we still use plus minus, but not in percent. So for example, when I say the test score for your first test is 73 plus minus 9. So this 73 is what we call as your best point estimate. And how do I get 73 is I do the sample mean. Means I take all your test score, I add it up and divide it by 30. And that is how I get the 73. And the plus minus 9 is called the margin of error. And you will figure out, that's a formula to figure out. But as I told you, you do not need to worry about the formula. Your StatCrunch will handle that easily. So, so last time when you do population proportion, we do what we call as a standard normal Z. So for this case, we won't talk about standard normal distribution. We're talking a new distribution, and that distribution is called the T distribution, the student T distribution. This distribution used a lot in a lot of places. So standard normal, not too many, but student T is used quite a few. Why student T we use quite a lot compared to the normal in this case is because student T distribution is very similar to normal, but you do not need to worry about your sample size. Remember last time when you do the normal population, it says that your population has to be normally distributed or your sample size has to be more than or equal to 30. Oh, do I record this? Yep, I did. So this is for the Z distribution, the normal standard normal distribution. But when you do a T distribution, this condition is robust. Robust in this case means that loose. The condition here is loose, means that you do not necessarily need to have more than 30 samples. So it also works when your sample is small, like 10 or 15, as long as there is no outliers. So this is the only thing that they will mention, they will talk about here is for T distribution, this is robust, means it's loose. That means you still can use a smaller sample in this case, like 10 or 15 students. Because like right now, we only got 29 students, right? There's no 30 students out, which is still. So if I have a smaller class, like 20 students, I cannot use the Z because Z says it has to be 30. So the T distribution will be used here. So what happens to the T distribution? So if your sample is small, like 5, then your distribution is also looks symmetrical, looks like normal. The tail here is thicker. You can find out that this tail is thicker here, thicker tail. Your mean in this case is 0. Your standard deviation is more than 1. And if you remember Z always have the mean is 0 and the standard deviation is 1. But for a T distribution, your mean is 0, but your standard deviation is more than 1. And if your sample size is small, you got thicker tail. What happens if your sample size increased from 5 till 10? Then the tail is no longer that thick and it will push up a little bit. Okay, so this is when your sample size getting bigger. So when your sample size gets to 20, like 30, then this will get small and then it will push even higher than that. And if your N is getting larger and larger, this will not change a lot because it's still, and then still go up. So you still have a smaller tail. But what happened is this, when N is getting large, your T will be very similar to your Z. Okay, so this is what happens to your T distribution, which is very important distribution. So there's other properties that we just talked about is right here. So the student T distribution depends on what we call as degree of freedom. How do you find your degree of freedom is n minus 1. And this is the, if you need to know what is the definitions of degree of freedom, that is the definition of degree of freedom. What does that mean when I say your degree of freedom is n minus 1? Degree of freedom is actually the number of the sample values that can be varied after certain restriction can be imposed. Why this is n minus 1 depends on your sample size is because let's say, this is something that I always tell my students how I figure out degree of freedom. Let's say I give you guys 30 students of you guys, I give you guys a test. Out of 30 students, 29 of you wrote your name down. I know you all wrote your name. One did not write your name down. Do you think I can figure out this student's name?
Yes.
Yes, I just put in the task, right, in your grade, and the last person that doesn't have a score, let's say is Andy. Andy will be the one, right? So that's why it's called n minus 1, is because if I got 30 students, if I know 29, which is n minus 1 here, 30 minus 1, if I know 29 names, if I doesn't know one of those names, it's fine. But what happens if I only know 20, only 28 of you guys wrote your name down, but 2 of you doesn't write your name down? Do you know who is these 2 students will be?
No.
No, because then I have to guess, right? I put everything, all your scores in the test. I got 2 students left, Andy and John. So I'll be like, okay, either this is Andy or this is John, right? So, so we doesn't know who is this person is. So that's the reason why that they take n minus 1. Why it's not n minus 2, n minus 3? Because you can only have up to 1 person who haven't write your name. So that's the reason why that when you this is called the degree of freedom, means that how many names do we need to have, so that we need to know so we can do calculation. So out of 30 students, I just need 29. Okay, so it's n minus 1. And properties, which is the same thing as the picture. It looks, this is not nice, but if you go to your textbook on page 319, it's nicer. Okay, sorry for, I kind of like killed really brutal this T distribution graph. So what you need to know is T is a bell shape, like what we just did just now. It has a mean of 0. The standard deviation is greater than 1. That's what I just pointed out. And then if your n is getting larger, your t will be getting closer to your z. Okay, so this is what we just written down all over here. That that we talk about here is, it is a bell shape. They all looks like bell shape. With the mean is 0, the standard deviation is always more than 1. And when n gets bigger and bigger, your t will be closer and closer to the z. Okay, so this is the T distribution. So there are some new notations you need to know, because this is mean. Last time we did proportion. So for mean, we got this symbol mu. This mu is called the population mean. And the X bar is called the sample mean. So make sure you guys know the difference between the population mean and sample mean. Some students ask me, how do you differentiate this? In statistics, if this population, they're all going to be in the Greek letter, like mu, sigma, alpha, beta. So those are all in Greek. So it's mostly talk about population. If you in alphabets A, B, C, D, E, then it will be sample, like X bar will be sample mean, P hat will be sample mean. But before forget, proportion, P is population proportion. So make sure you understand those stuff here. S is the sample standard deviation. Okay. N is the sample size. E is the margin of error, the one with the plus minus. Okay. And then T alpha over 2 is called the critical value. So last time the critical value is Z alpha over 2. The reason we use Z is because it's standard normal in chapter 7.1. So in this one, we use T because it's a T distribution. So we use T alpha over 2. Do you still remember how you find your margin of error last time in this, in in this case. Now if
Upper
I,
minus lower divided by 2.
yep, so this one is the same thing. So when you use your StatCrunch, they always give you the upper and lower. So in order for you to find the margin of error, you have to take the upper minus the lower divided by 2. The same steps, the same way that you find your margin of error in 7.1. Okay. So the requirements, it has to be simple random sample. So if you can tell that a simple random sample is always the first requirement, no matter it is proportion or mean. And then the second one is that it is normally distributed and n is greater than 30. And I told you before, this second requirement is loose. The reason why is because you can still use a smaller sample size, but make sure that it does not have any outliers. I just point out to you about this one. So how do you figure out if let's say you only got like 15 students instead of 31 or 50 15. How do you figure out outliers? It's very easy. You draw the box plot. Remember last time in your midterm test, you draw the box plot. If you see any dots outside, it's outliers. So this is how you do it also. So if you have only 15, 20 students, you take that students and draw a box plot and see if any dots outside. And what happens if the dot plots or the box plot shows dot, means shows outliers, means this is no good. Okay, so if outlier exists, second condition will not met. Okay, so this one, so make sure you watch out for your outlier case in this case. Okay, if you have a smaller size. Rounding, I'm not very picky at rounding. So same thing with your tests or your midterm, 2 or 3 decimal places, just to be in just safe, 2 or 3. Just do 2 or 3 decimal places. Now, this is where you find your margin of error using the formula. So do not look at this. So again, how do you find your margin of error? Is you just take the upper minus lower divided by 2. Same thing as the first section you do. So how do you use your StatCrunch to do this? In order for you to use the StatCrunch to do this, you have to go to tstat one sample. Now, when you then you got 2 choices. Either you do data or with summary. So what is the meaning of with data? With data means that your data is given to you, or the data files like like the bears and or your homework when you import all your data into your StatCrunch. That means you have to do under data. What is with summary? Summary means that the questions give you the summary statistics like the mean, the sample, the standard deviation, the n, and so on. So so make sure you guys need to know which one is which. For example, is if you read this question 2, this one comes from the data called chips. Okay, so that's the reason why that this you have to use the first option because it comes from the data file. So anything that it has data, all the numbers in there, you use the first option. Like number 2, they give you this how many babies, this is the mean, this is the standard deviation, and so on and so on. So since this question already provide us what we call as the statistic, these are called the statistics, the mean, the standard deviation, then you will pick option number 2 to do it. Okay, so make sure you know which option to use, and it's pretty much straightforward type. Then when you use your StatCrunch, they always give you the upper limit and the lower limit, which is the lower limit first, and then the upper limit, upper. So which is this case, and you can always write this in terms of like a number, like 56, less than mu, less than 79. So last time, if you remember, we don't use mu, we use p, 0.85, p, and then we use p. P is for population proportion. This is for 7.1. So now in 7.2, we won't use p, we use mu. Mu in this case means your population mean. So make sure you guys, when you guys want to write in this format, make sure you use mu here instead of p, okay? I will take points if you do that. And you also can write down as x bar plus minus e. Again, e is using upper minus lower divided by 2. X bar is a sample mean. You can find taking upper plus lower divided by 2. So instead of minus, you can add them up and divide by 2. This is how you find your mean in this case. Okay. So interpreting confidence interval, the same thing. We are 95% confident that the interval from 56 to 79. The only difference between this and the proportion is you need to have units. So because this is all in quantitative variable, so 56 to 79 score, if you're talking about test score, you know, actually does contain the true value of the population mean. And again, this is mean here. In 7.1, we use proportion P, okay? So in 7.1, we will use proportion P. So that is it's actually the same thing. It's just changing the mean to proportion, okay? And again, these are the wrong way to do it. You don't use the word chance. You don't use the word sample. So please don't. It's the same way to interpret it. So don't use the word chance. Don't use the word sample. So these are the upper and lower. We talked about this already. How you find your margin of error. You guys all right here? Anyone have it? It's very similar to what you did last time, but this is just me.
I do have a question. It's from a little bit further back. So when you were talking about the n-1, and then you said if I have 30 students and one does not have their name, it's easy to find. But then when you did -2 students, I kind of didn't understand what you meant there.
Because I have a list of students, right?
Mm-hmm.
I got all 30 students here, right? Mm-hmm. And if 29 of you wrote your name, I can put scores. Oh, you got 70, she got 71, so on, so on, so on. Finally, there is one of these guys doesn't write the name, right? Mm-hmm. So I can figure out this person name. Mm-hmm. Right? Because I got 30 students. So that's why it's n-1. But what happens if 2 of you guys doesn't write your name? Then I have a dilemma, because this test can belongs to John and it can belongs to Andy. You know what I'm saying?
Yeah, I understand that. I just don't understand it in terms of like.
That means that when you have the whole total of students, mm-hmm. we just need 29 students data.
Okay.
One of the students, you do not need to get the data because we can figure out ourselves. And that data we know is who.
So no more than 1 student.
Yep.
No more than -1, I guess.
So that's why the n-1 because of this one.
Okay.
You cannot use n-2. The reason why is because if you have 2 students without names, we do not, then we have a trouble, because then, you know, we don't know who is who.
Okay.
So that's why your degree of freedom in this case is n-1. That means that out of the whole students, if one of you doesn't do anything, I know who this person is.
Okay.
The rest, if the rest did the work and one of you doesn't do it, I know who is this person. But if 2 of you doesn't write your name, didn't do anything, then I have a question now. It's like, okay, who is this? Is that Andy or is this John? You know what I'm saying?
Yeah. So where would we deal with n-1 in our homework or exam?
When you guys, they will ask you for degree of freedom. So especially when you guys calculate see that when they're asking for test calculators, when you find a T alpha over 2, they will ask you for degree of freedom. Mm-hmm. And make sure you don't use n. You should subtract it from 1.
Okay.
Mm-hmm. So that they will specifically ask for degree of freedom. Mm-hmm. I'll show it to you. Yep, I'll show it to you. Yep. So 7.2 is the homework. So
I have a question for 7.1.
Linda, can you talk to me after class?
Yeah.
Yep. I've been asking that since beginning of class, so make sure you, once I move on, I'm not going back, so ask me after class. All right, 7.1, 7.2, so this is the result. They give it to you. So if the question already give you a result like this, you do not need to do calculation. It's because the top one here is your confidence interval. This is your sample mean, this is your standard deviation, and this is a sample size 50. So by looking at this, can you tell me what is the confidence interval will be in 2 decimal place? The result is right here. And this is your answer here. See that?
13.05.
And 22.15. So if a question give you all this information, you just need to know, just read. Just need to know how to read it. So this is how you find your confidence interval. What is the best point estimate? So if you remember, the best point estimate for a population mean is your sample mean X bar. So can you tell me what is your sample mean X bar here?
Is it 17.598, but if it's 2, then it's 17.6?
Yep, that is correct. So which is your sample mean? Margin of error. How do you find your margin of error again?
Upper minus lower divided by 2.
Yep, upper minus lower divided by 2. So take out your calculator. Can you help me to subtract this and divide by 2? Make sure it's positive. So make sure you take the upper minus the lower. Same thing you did on 7.1.
$4.552.
So it's 4.55 since
Oh yes.
2 decimal place. So this one is 2 decimal place. And now in constructing the confidence interval, why is not necessary to confirm that the sample data appear to be from population normally. So if you remember when you talk about conditions or requirements for this, it is normally distribution or what? The sample size is more than 30. What is the sample size in this case?
50.
50 right here. So the reason why that we do not worry about the population is normal is because the sample size is 50 in this case, which is more than 30. Okay, so that means, again, this is or, so it means you can have either this or that. Okay. You okay here? Question 2 is the same thing. They give you this. And now they want you to find what is the number of degree of freedom. So how do you find the degree of freedom?
N minus 1.
N minus 1. And N in this case is
50.
50. So this will be
49.
49. So that's, so for Cecilia, you're asking that. This is usually what they will ask you. Very straightforward.
Okay.
They won't give you, yeah, they will ask you, this is the, they want you to find the critical value. So how do you find your critical value? This is how you find your critical value in your StatCrunch is stat calculator T. So, so in your StatCrunch, you go to stat calculator and T. You see that? Last time we do binomial, normal, and custom and all this, you know, now we do T. Okay, and the first thing they ask you is DF. DF is the degree of freedom. In this case is 49. Okay, because you got 49 here. Next, you need to figure out your X equals and change this to become greater than. So make sure you change this always to become greater than. And then this is the empty part, and then alpha over 2. So if you look at this, what is alpha in this case? If I'm asking for a 95% confidence level,
0.05.
alpha
0.05.
will be
Yeah.
5%, 0.5. But don't forget, we need to divide this by
2.
So you don't need to do the math, because what you need to do here is you just put the alpha divided by 2.
I'm sorry, could you repeat how we got to the T calculator?
Under stat calculators T.
Oh, okay.
Okay. So, and then you will get this. And then you put the degree of freedom is 49. Make sure you change this always to greater than or equals to. So do not use a less than. And then this is alpha over 2 is 95%. So alpha is 5%, 0.05. And this number is your answer. In 2 decimal place, 2.01. You guys all right? This is the definitions of degree of freedom. So it should be the same as, that's what this is. It's a collection of sample data with number sample value with after the certain restriction is been applied. So it's exactly the same. So make sure you you know which one is matched with this one. I think it's after this one. It should be the exactly matching. You know what I'm saying? And that is the definitions of degree of freedom. Yeah, I think it's that one. So you know you can get this note from D2L, right? I post all these notes in D2L. So make sure you get them from make sure you go through this in D2L. Okay. Number 3. Again, they give you this. They want you to interpret. Remember how we interpret confidence interval? Is that A, B, C, or D? Very similar to what you guys learned in 7.1.
That would be B.
That would be B. 95% confidence that this is between well, the true value of the mean of the population or population mean. You okay here? So it's very similar to what you guys do in this case, okay, in 7.1. This is the one that is different. So I'm going to teach you how to do this. So in question 4 in 7.2 here, they're asking us which one of these is appropriate to do this. And this kind of questions will be coming up in your finals as a multiple choice question. So yep, this is the one that I love to cover in multiple choice question. So so is that T alpha over 2? Is that Z alpha over 2? Or is that neither? Okay. So first thing first is one of these. I'm going to talk about neither. In order for you to pick neither, you did not meet the requirement. Means that your population is not normally distributed and your sample size is less than 30. Okay, so if you have such case here, then you have to pick neither. Okay. In order for us to pick Z alpha over 2, sigma is given to us. In order for us to pick T alpha over 2, S is given to us. So we always do the neither one first. If neither one does not pass, then you look at if S or sigma are given to us, then you pick T or Z. So first thing first, if you look at this the statistics here, can you tell me is this neither? Yes or no?
No.
because your sample size is
244.
big, 244. So it's not this one.
Is
Next is S or sigma given to us.
As
it us?
S, so it's not this. So your answer should be T. A. And how do we find this number? You have to use your StatCrunch. What is the degree of freedom in this case?
243.
243. So don't put 244. Again, make sure you put greater than a blank. What is my alpha here? Oh, my alpha is 95%. So alpha is what?
0.05/2.
Same thing, 0.05/2. So this is your answer for him. So 1.97. You guys all right here? Now, what happens if you use Z alpha over 2? Z is your standard normal. So if you are picking this one, then you will use calculator, you use normal. This is for the Z. So if you are using Z alpha over 2, the mean is 0, the standard is 1. And then you make this as greater than, blank this, and then this is still alpha over 2, which is in this case is this one. So 1.96. So if you are picking this, your answer will be 1.96. If this is for Z. So Z, you use normal calculator. T, you use the T calculator that we have. Okay. So make sure you know the difference between T and Z. So one is for T, one is for normal. Normal doesn't ask for degree of freedom. Normal just asks for mean and standard, which is 0 and 1. But for T, you ask for degree of freedom in this case. You guys all right?
Yep.
So this one is asking us to find the confidence interval. So if you look at to find the confidence interval, we got two choices. Either is from data or summary. So when you read this question is given us the data or is given us the summary?
I think it's
Do they give you a bunch of data?
Oh,
Or do they give you
summary.
the mean, median, a mean, standard deviation, and so on? So this
Summary.
given us summary, right?
Mhm.
So you will use the second option. So how do you find the confidence interval here? Is close all this. You go to stats, you go to T-stats, one sample with summary. So with summary means they give you the mean standard deviation. With data means they give you the data. So make sure you go to T-stats. Last time we do proportion stats in 7.1. So now you do T-stats, one sample with summary. And they will ask you to enter this information inside. So what is the sample mean in this case?
98.9.
98.9. Sample standard deviation,
0.65.
sample size.
103.
Yep. Now do not just move down to here to put the confidence interval. What is the confidence level that they want you to find?
99%.
99%. And you hit compute. Where's my result? There you go. Sorry, it's hidden. So this is your lower and this is your upper. So your lower in this case in 3 decimal place, 98.732. And upper in this case is 99.068. And the only difference between mean and proportion is, again, mean is T, proportion is Z, and then mean you have units. So this one you see the degree of Fahrenheit, degree Fahrenheit. So that's the unit for this case. Ooh, wrong. Let me see why this is wrong. 7.3.
Oh, it's 98.732.
Oh,
I accidentally
90.
did 98.7.
Sorry, not 97, 98. Okay, there you go. So now, so this is what we consider as normal temperature for human. So if you measure 98.6, is this higher, possible, or lower? So another meaning they ask you is 98.6 is inside or outside this range?
Outside.
Is that on the lower end or the significant low or
Oh,
significant
98 point. It's a
Lower.
lower.
on the lower side? So this suggests, now a lot of people pick this, you will get it wrong. The reason why you get it wrong here is because they're asking for the mean temperature is lower than that. This is the mean temperature. Actually, the mean temperature, is that lower or higher than 98.6?
Higher.
Higher.
Higher. So just want to point out to you that they like to play on words here. So they're asking for this mean temperature is higher than that. Or sometimes they like to play 98.6 is what? Lower
Lower.
than the mean temperature. So
Tricky.
that's tricky. You're correct. So make sure read the question carefully which one they put first. Okay, since the mean body temperature put first, so in this case it's high. So they are tricky. And again, in my test, I try my best not to be as tricky as this is very tricky actually. Same thing happens with this question. Is this gonna be data or is this gonna be summary?
Summary.
So I'm gonna use back. So I use back edit to just change back. So you just type in all the stuff. You guys know how to do this one, right?
Mm-hmm.
What is your mean in this case?
104.
No, that is not.
80.6.
Oh,
Okay, so okay,
Mean wake time is 80.6.
mean wake time for the before treatment and after treatment is given this. Assuming that's it, you know. That tricky now. What is
the treatment.
I think they're asking for before with the treatment. So with the treatment means after, right?
Mm-hmm.
So that means you don't look at that one. So again, tricky here. So read the question. So 80.6 is the mean and the standard deviation is 21.3. Sample size is how much we have? 16, right?
Mm-hmm.
And we're looking for how many? 90% confidence interval. So yeah, just be careful, kind of tricky here. So so this is your answer for your upper and your lower. So your lower in 1 decimal place is 71.3 and your upper is 89.9. Okay. Now so this is something I want to point out to you guys. Okay, so this is talking about drugs, right? So this is something I want to point out to you guys that, so if a question is asking for drugs and if they want to figure out if this drug is effective or not, okay, so you will find the confidence interval, right? The lower and the upper that you did just now. So if the number that you have falls inside this, you have no effects. However, if your number falls outside this, it will have effects. Okay, so this is for drugs. So if you take these drugs and then before I know, if these drugs show any effects to the to the symptoms. So if your number falls here, no. Outside, yes. So what we found out here is this number is what, 71.3, right? And what, 89.9. And they're asking you for what number here? They're asking you for 104. Is 104, where is 104 at?
It's upper. It's significantly higher.
This one, this is 104, right? Right here.
Yeah.
So does that have effects or no effects?
Yes. It has.
It's effective. So in this case, the confidence interval does not or does include. This is the confidence interval. This is the confidence interval. Does it include or does it not include the 104? That means, in other words, is 104 inside or outside that?
Does not include.
So it does not include, this is outside, so it does not include. So the mean before and after the treatment is, so we know this is as the result of the drug treatment has effects, okay? So, so when you have no effects, there is no difference. I think it's no different. Yep, and this one has difference. Yep, because they are having different. So, so in this case is this. So the before and treatments have difference. Yep, because of effects. It's the same. Yep, I think this is correct. Yep. So, so every time, this is for drugs. So every time when a question is asking for any drugs that has, does it has effect or no effect? So if your number falls inside this confidence interval, with no effects or no difference. If it's, in other words, it's same, no difference, the same thing as same. But if your number fall outside the confidence interval, it is effective or it has difference. You guys all right here? Tough. Right, this is the same thing. This is another drugs. Oh, this is the same. No, sorry. This is the same question. My bad. Oh, yeah. Sorry. This is also another drug called garlic. Which is the garlic. So read this. Is this data or is this summary? Summary. So you can. I will do an example about data. Sorry. And we're gonna put some little numbers here since it's summary. So what is your mean here? Sample mean?
3.9.
Standard deviation?
19.8.
Sample size?
45.
45. And the confidence level?
90.
Okay, good. It's always hidden somewhere there. There you go. So the lower limit in this case is negative. So negative 1.06. And the upper limit is 8.86. Okay. Now for this case, they use 0. Okay. So when you go to chapter 9, we always use 0 because when you use 0, it's telling us 0 means it's no difference because 0 means no. If you have more, it's negative. Positive. If left, is negative. Chapter 9, you'll learn this. So now what we have here is we have the score of what? 70 something, right? Negative.
Why is it that we can use a negative in this case?
Because this negative means that there are people shows the other way, means they are showing no improvement, and it's actually given a negative effects. You know what I'm saying? So when you take a drug, you can have no effects, you can show positive effects, and you can also show negative effects.
So like more cholesterol in this case?
Yes, in this case, it'll be no good. So in another case, yeah, that's people show up actually if you take garlic. In this case, the negative shows they have more cholesterol. So this will.
For some reason, I enter in like what you guys are doing, but I'm not getting the answer.
Do you? Do you go to stats, T-stat, and one sample?
Yeah, with summary.
And what do you enter?
So for the subjects, the sample size would be 45. And then
Where you put 45.
in the sample size,
Okay. And then,
and then the mean is 33.9,
uh-huh.
and then the standard deviation is 19.8.
And then,
And then the confidence interval,
you click on this one, right?
yeah, is 0.90 for that, right?
And then compute.
Yeah, but for my problem, I know I have different numbers and I did like the exact same thing, but I'm not getting the right answer for my.
Everyone, I want to point out everyone has a different numbers.
Yeah,
So your answer will be different from my answer. Yes. So this is the answer for my case. Yours should get different answer. You should get correct.
okay, I will try again. I probably entered it in wrong.
You have, yeah. Again, I'm doing my work. I'm not doing your work. You have to go home and do your own work.
No, I know that.
And your answer is going to be different from my answer. That
Okay.
I can tell you that. It's not going to be the same.
I think I got it now. I just entered in the wrong number for mine.
Yep. So if you enter wrong number, then you will get wrong answer. So so this is negative 1.06. And this is 8.86. And they're asking for what? 0, right? So can someone tell me is 0 is where in this confidence interval? Inside or outside?
Inside.
0 is inside here. Because so since 0 is the confidence interval includes 0 or not includes 0? Contains or not contains? It contains, right?
Yeah.
So is that effect or no effects?
No effect.
No effect.
No effect. So your answer will be B. So it contains 0 and it has no effects here. You guys all right? So make sure you're answering the numbers correctly. So you won't get wrong. Okay. Now this question is no longer sample, no longer statistics, because this question is given us what?
Data.
Data. So either if you want, you can be a hardworking student and you can enter all this number in, you can type it in var1, like 5, 7, 2.
But can't we just use StatCrunch?
Yeah, no, yeah, you enter it like this. Or if you do not want to enter it, this is not bad. Then you just open in StatCrunch, right?
Yes.
So either way is fine with me. But I want to point out to you that in your finals, you have to do what?
Enter it manually.
Enter manually because you cannot open in StatCrunch. So in this case, this is talking about male subjects rate females how attractive they are. 1 being not attractive, 10 is extremely. So this go for dating. So this is a guy that rate female, which is so in order for you to find this confidence interval, you go to stat, you go to T-stat, 1 sample, now with what? With
Data.
data. The data is under ratings. If you put it over on this, it's under what?
var1.
Yep, var1. Leave everything and then make sure you click on the confidence interval. And what confidence interval they want you to find?
90.
90. And you hit compute. And this is your answer. It's pretty much easy here. 5.63, or 5.6, sorry, 1 decimal place. 5.6 and 8.0. So this is how you do this. If they give you data, you just need to go to data. Now, what does this confidence level tell us about the female? Usually we say, well, we are 90% confidence that this one, right? We are 90% confidence that the interval from 5.6 to 8 actually contains the true value of the mean, right?
Yeah.
This is usually what we did. But for this question, is special is because your answer will be B. Does anyone know why that based on this, it's not representing the sample population of all adults, males, females? You know why we're using B here?
Yeah, because it's somebody's like just opinion.
You are correct. This is just someone's opinion. So, and these numbers are really, and the other thing is your sample is very small. So that's the reason why that, so everything that is based on own opinion or something like this, we would not try to interpret this. Usually it's A, the answer is A, but since this is not about, not random, not, so it's gonna be B in this case.
I
Question.
have a question. Oh.
Nope, Cecilia, you go first.
I have a question about, okay, so just to make sure that I get the calculators right, for TA over 2, where the S is given, we're using calculator to ZA over 2.
Yeah.
Or I mean, yeah, T calculator. We're using, so ZA over 2, we're using normal calculator.
Normal calculator, yeah.
And then for the confidence interval, when we're given a summary with data, we go to T-stat 1 samples with summary.
Then you put all this number in there.
And then this one that we are just doing now with the data, it's stat 1 sample with data.
With data, with data. And then they will tell you where is your data at column. So in this case, it's rating. And then you go to the confidence interval and then you compute.
Okay.
Yep. Practice.
Okay, thank you.
Yep. It's not that. Same thing happens in this question 9. This is about sushi, the amount of mercury in your sushi. So so again, you open in StatCrunch and then do the same thing. Go to stat, go to T-stats. Oh my God. And then 1 sample with data. And then over here will be the sushi, the sushi thing that you have, and then you will able to then put in the confidence level, and then you will compute it. So majority of this is pretty much very straightforward type. So they are the same. This is the same thing. And this one is a lot. So if you look at this one is a lot. So when you do this question on number 11, so I'm gonna open in StatCrunch. So this one has quite a lot of data here. Males and females, you need to read the question carefully. So this question is asking for male or is asking for female? This is asking for females. So when you go to here, you go to stat, go to T-stat, go to 1 sample with data. You make sure you pick the female one, not the male ones. And then they're asking for what? A 90% confidence, right? So this is the female, sorry, for 90% confidence, 72.6 to 79.9. So this is the heartbeat for females, pulse rate, sorry, not heartbeat, pulse rate. And then the next one they ask you is male, okay? So they ask you for male. So how you do this is go back to your option, go to your edit, deselect your, select your males now. Just click your male, so you automatically put on male. And you're also asking for 90%, so this is good. So the male one is 63.9 till what? 70.5. So this is the male one. So the question is asking here is, do these two confidence interval overlap or they do not overlap?
They don't.
They don't. And can you tell me which one is higher?
Female.
So in this case, they do not overlap, and it figure out that female is higher than male in this case. So your answer is B. You guys all right? It's pretty much, this is pretty much very, if you know how to do 7-1, 7-2 is kind of the same thing. So this is restaurant X, restaurant Y. Again, repeat that. This is going to be the same thing. They ask you for restaurant X, and then I ask you for restaurant Y, and then they ask you, did they overlap or not? Okay. You guys all right? And the rest of this is mostly, you can do this. So this is 7.2. So make sure you go through. This is not that tough. You're able to do this. So this is chapter 7.2. Anyone have any questions for me?
Not necessarily about the homework. I wanted to ask you when class first started. Did you do something different with your hair?
No.
Oh, well, it looks good today.
Oh, thank you. No, no, I didn't do it. I didn't even comb. All right. So next, so chapter 7 is talking about confidence interval, and then chapter 8 is doing hypothesis testing. Now, this is the one that is gonna be. You guys need to really pay attention on this one, because confidence interval is very easy, right? Because you just go to your StatCrunch, you put this, and then boom, here's your answer, right? Here's your answer, and then you try to understand that. But chapter 8, when you do hypothesis testing, what is the hypothesis testing? A hypothesis testing is where you test about your claim or a claim or statement about the population. So this claim is called what we call as a testing claim. Or sometimes if you're doing a thesis, this is your thesis statement, your research statement. So usually when your claim statement here, your claim statement always have the word either greater, less than, or equal to. So when you guys read the claim statement, they usually have these 3 big words came out, greater than or less than. If I'm running for president, I want the population who vote for me is greater than 50%, or the electoral votes is greater than, I don't know what number, 335, or I don't know what number is that. So that is the number that I'm looking for, right? So so that is what the claim statement is. So it's always have greater, less than, or equal to. So when we do the hypothesis testing, we always talk about population. So like when I say greater than 332 is talking about the whole population. I'm not talking about sample here. And in order for us to figure that, we use sample to calculate and to predict the population here. So when you guys do a hypothesis testing, this procedure is a 7 steps procedure. Yes. So you will get so tired of this. And so it's 7-step procedure here. And so it will be 1 to 7. And you're gonna use this in chapter 8, chapter 9, and chapter 10. So you'll be doing this 7-step procedure over and over and over again in these last 3 chapters here. So you will get used to it. So the first time you use it, you see it, it's kind of like new to you. It's a bit hard, but once you get into chapter 8 and chapter 9, you're gonna get, all right, same thing, same 7-step procedure, no change. Okay. The first step is requirement check. The requirement check depends on mean and proportion. So proportion, you have 3 requirement checks. Mean, you have 2 requirement checks. We did the mean before on 7.2, which is it has to be simple random sample, short form SRS. And also your population is normally distributed, or your sample size has to be more than 30. So this is the robust, the loose requirement. For proportion, the 3 requirements is also simple random sample, binomial, and at least 5 success and 5 failures, at least 5 failures. So this is the requirement for the proportion. So usually when you do your thesis and your research, if you did not fulfill these requirements, you don't need to do the rest of the steps. But for this class, if one of these requirements did not pass, you still have to continue going through the 7 steps procedure. And in your test, this one worth like 12 points, 10 to 12 points. So that's why the confidence interval is probably worth like 3, 4, 5 points because it's not a lot of work. This one is a lot of work. So you can tell by looking at your, I just gave you 8.2 question looks like. So if you look at 8.2, this is what you get in my test. Just one big like this. And you have to do 7 steps here. And that is where the 10, 12 points, you have to do requirement check, you have to write this, you have to do all these things you have to do. This is exactly what you will see in my test. So that's the reason why I need to teach you guys. It's very important. This is very, very, very important. Okay. So, so this 8.1 is just the basic of this. So what we're doing is they break these 7 steps into individual steps. So they use step 1 first, and then step 2, and then step 3. And then at 8.2 and 8.3, they combine all these 7 steps into one big hypothesis testing. Okay. So, so step 1 is requirement check. Step 2 is writing the hypothesis. So there are 2 hypothesis statements you have to write. One is called the null hypothesis, and one is called the alternative hypothesis. We are lazy to write this, so it's too long. So the null hypothesis, we denote this as H0. And your alternative hypothesis, we denote that as H1 or HA. Your StatCrunch use HA. I'm okay with it. If you use H1 and HA, I'm fine with it. Okay. So do not use whole and half. Okay, please, please, please. Oh, it's whole and half. HO is whole, HA is half. Do not do this. H0 and H1 or HA. Okay. What is a null hypothesis? The null hypothesis is where the population is always equal to some claim value. So in other meaning, no change, no effect, no difference. So your null hypothesis is always talking about that is no change or no effects. But your alternative hypothesis is where the parameter is different from the value. So we always use less than, greater than, or not equals to for alternative hypothesis. So another meaning when you give me the hypothesis statements, either we use P or we use mu. So P stands for population proportion. So you use this in 8.2. Mu is used in mean, 8.3. Okay. So this 0.5 that you see here is what we call as your claim value. And this claim value comes from your claim statement. Okay. So this claim value comes from your claim statement. So when you guys read the questions, they always give you the claim statement, and that claim statement usually has a number on it. So for example, again, I give you 8.2. You can see the claim statement here. So if you read this question in 8.2, there is a claim statement in this case. Anyone figure out where is a claim statement? I'm taking attendance now, so please, while you guys read, can you attendance, chat room present? Thank you.
67%.
It's more than 6.
Less than.
Yep. So this is a claim statement. Actually, the claim statement is the whole thing.
Okay.
So make sure it's not just the back part. So the whole, so underline, that is the claim statement. So if I want you to write a hypothesis test, the statement in this case. So how do we write the statement for this case is H0 P equals to 0.67. P is for proportion because we're talking about percentage here. The 0.67 comes from the claim statement. And for H0 is always has no effects. No effects means equal to. But for your alternative hypothesis, your P in this case will follow your claim statement, which is less than 0.67. So this is how you write your hypothesis statement. You guys with me here? And yes, I have to give you the claim statement when you guys do the work. Okay, let's do it one more time for you guys. I want you guys to read number 2 here. Teaching you guys how to do the claim statement. Can you find the claim statement here? And in the test, I recommend you to print it out so you can underline it.
More than 1/4 of the people say that bosses scream at employees.
Yep, this is a claim statement. So how do you write this in your hypothesis, H0 and H1? You should use P for proportion or percentage. Does anyone know a quarter in percent?
25.
25% or 0.25. I'm okay with 0.25 or 25%. So again, this is always equal. So don't forget your P is always equal. What will your H0? What is the alternative H1 will be?
I forgot.
It'll be more than. More than means it's greater, right? Than 0.25. Okay. So this is more than, not more than, it's more than.
Oh,
so that,
yeah.
So you use greater than. So so make sure you guys know that if they're asking for less, you use less here. If it's asking for more, you use more. So this is what we call as step 2. Write your hypothesis statement. Okay, write your statement here. Okay. Now, as you know that it can be less than, it can be more than, or it can be equal to. This is the one that I tell you. You always have greater than, less than, or equal to. So when you guys do a right tilt test, this is the picture. Sorry, because I cannot draw the picture over there. So when you do a right tilt test is where you will use right is on the left, right is on the right side. So it's greater than. So if you have a test that is using greater than, then you will have what we call as a right tilt test. This is right tilt test. A right tilt test is where you will your shading area is on the right side because you use more than. Like the one that you use more than a quarter of a boss scream at an employee. And if you have a left tilt test is where you use less than. And for this case, your shading area is on the left. And if you have a 2 tilt test, a 2 tilt test is used when you have not equals to. The reason why we call this 2 tilt test is because it is both sides. Okay, so when you do a left tilt, right tilt, and a 2 tilt test here, this line that we draw is your critical value. Okay, so this is Z alpha, this is Z alpha, and this is Z alpha over 2. The reason why that the first 2 picture is Z alpha is because you only got one side. This is your alpha. So remember last time when you do your confidence interval, I say 95% confidence interval means the 95% is right here. This is your 5%, your alpha. And if you want to do this, the 95% is right here. This is your 5% alpha. But for this case, your middle part is 95%, but this 2 has to be 5% in total. That's why we have to take the 5% divided by 2 here, is because this 2 is exactly the same area. One of them is a minus and one of them is a plus. So that's the reason why when we do confidence interval, we do the Z alpha over 2. Because for confidence interval, we always have the lower and the upper. So that's why it's a 2. So 2 tilt test is what we do for when you do confidence interval. But sometimes it can be a left tilt, sometimes it can be a right tilt. So don't forget that alpha can change to become alpha over 2 if it's 2 tilt test or confidence interval, or it can just alpha by itself if it's a left or right tilt. So this is what we call as 2 tilt, left or right tilt. 1 or 2 tilt test. Test statistic. Test statistic is where you find out a value that is deciding that the null hypothesis in this case is true. So what is test statistic in this case? Test statistic is this value that you find, this Z value that you find. So if this Z value that you find is inside this critical region, then you are in the rejection. You're going to reject your H0. But if your Z value is inside the not rejection area, then you fail to reject H0. So this is what we call as test statistic. So remember last time when we did the garlic one, this is a negative something, and this is 8, 9 point something, right? So you find out 0 is here. So that means that that is this case. So you are in the fail to reject H0. But if your number is either this side or this side, then you will have to reject your null hypothesis. So that is the meaning of the test statistic is a number. So we use Z for proportion, T for mean, which is set one is Z is for set, T is for T distribution, Z for is Z distribution. Significant level alpha. So alpha is the 5% if it's 95%. So we call that as significant level now. So this is actually is the opposite of confidence interval. So 99% means alpha is 1%. Critical region is the shading area here. So this region is where you will reject your null hypothesis. So this whole area that I shade here is called rejection of rejecting the null hypothesis. So if your test statistic falls inside here, you have to reject it. Critical value is this borderline. So this Z alpha is your critical value. So these are all the names for it. So when you guys do your homework, you do not have to worry about your test. I won't come out with definitions, so do not worry about memorize this. But you make sure you know how to find it. So how do you find critical value? I think we did the one with alpha over 2. So when you talk about proportion, make sure you use normal calculators. When you use mean, you use the T calculators. Remember that we got 2 calculators in your StatCrunch, okay? And then make sure when for normal, the mean is 0 and the standard is 1. For T, n-1 is degree of freedom unifying. If it's a two-tailed test, make sure you put this is greater than or equals to, this is a blank, and then you put alpha over 2. I think we did this in 7.2, right? In the beginning of today's class, we talk about this one. If it's a left tail test, you just need to switch that greater than or equals to less than or equals to, but this time it's going to be alpha. The reason why we don't use over 2 is because left tail test, the whole thing is 5% alpha. You don't divide by 2. Same thing with the right tail test. You just need to flip the sign to become greater than, and then this is alpha. Is again because in the right tail test, your alpha is the whole 5%. You don't divide by 2. Same thing with the T calculators. Make sure you know left tail use less than, right tail use greater than, two tail use greater than with over 2. So this is more important than the definitions, I can tell you that. And next thing we're going to talk about is p-value. A p-value is the probability of getting a value to the extreme case, assuming that null hypothesis is true. So this is kind of like telling of p-value is telling us that how far is the probability can you go till you figure out, you know what, something is not going right here. So for example is if I give you a deck of cards and I say, what is the probability that you get a black card? And usually it's 50-50 because there's half of them is black and half of them is red card. So then, all right, then I want you guys to draw a card. So I call Kim, okay, Kim, you pick a card. And Kim say, all right, she pick a card. I'm looking for a black card and she pick a red card. Happens, right? And I say, okay. Kim say, okay, it's all right, no problem, right? Then I go to Latasha. Latasha say, and Kim keep the red card. So I say, Latasha, can you please draw a card? And she draw a card and it's also red. And then Latasha said, oh, 2 red cards in a row. Okay, nothing surprising, right? And then I go to Teresa and Teresa pick up It's another red card. So can you tell me until when you think this card is rigged? Like, you know, it's something wrong. The fourth person pickup is red, 4 in a row is red, 5 in a row is red, 10 in a row is red, 11 in a row is red, until you say, you know what, David, I do not need to pick that card anymore because it's going to be red. And it is true, the whole deck is red cards. So my question is, until what point you guys think that this deck of cards is red? Is David's, you know, something happens. That is what we call as p-value. So p-value is a probability to the extreme till one point you think of, I do not need to draw this card anymore because it's going to be red card, no black cards here. Okay, so that is called a p-value. And we're going to use that a lot in this class. Actually, we do p-value quite a lot. So finding the p-value inside in your StatCrunch is, again, we use normal and we use t. So last time, if you remember, if you using your, let me show it to you how you find. So last time, remember when you do the calculators using t, we always put the degree of freedom and then we change this less than greater than, and then we put this over 2 or something like that, right? So now, in order for you to find the p-value, you have to actually enter the score here. Let's say 2.3, and you let's say this. This is the p-value, the probability. See that when you click on it, that's probably. So when you find a critical value, you put in order for you to find a critical value, you put this over 2. Okay, this is how you find a critical value. This is the critical value. This is called reference value, which is critical value. And if you want to find the p-value, which is a probability, then you have to put this number down. And this is either your t-score or your z-score, depends on your so it depends on proportion or depends on the mean. So the only thing in the watch out here is when you have a two-tailed test, you have to double it. So every time when you do a two-tailed test, when you compute this, and let's say this is 2.3, you get this number. See, if you look at this number is only one tail to the right. So in order for us to have a two-tail, the reason why I say you have to double it is because this probability is 0.022. And guess what? This probability is also going to be 0.022 if you have a two-tailed test, because they are the same. So that's why you double this or you add them together, which is 0.044. So this is only happens when you have a two-tailed test. You find the probability and you have to double it. Otherwise, if it's a left or right tail, that is your answer. Okay. So this is the how you find the p-value. How do you find the p-value in this case? So some students ask me which one is more important. So you want to transfer this into your test, right? Remember your test, you're allowed to have one piece. I can tell you critical value is more important than p-value, because usually in your tests, in your StatCrunch, they will give you the p-value. So I would recommend, if you want these two tables, but if you are running out of space, then I would recommend you to write critical value in this case. Okay, but this whole page 5 and 6 is the one that you have to write on your paper, because this is for sure is a must. So step 5 is making decision, and step 6 is conclusion. So making decision is looking at the p-value that you find, which is found in here, and the alpha, which is the significant level, like 5%, 10%. If your p-value is less than alpha, you will reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. And with this, you can do the conclusion. Now, your conclusion has 4 choices, okay? The first 2 choices is where your claim does not have equality. Means if your claim is using less than, greater than, or not equal to, then you will have to do the first 2 choice. Otherwise, if your claim has an equal sign, then you will have to use the other 2 choices. Okay, and then you have to figure out, are we rejecting or fail to reject based on the 5th? If you are rejecting, then this is your conclusion. There is sufficient evidence to support the claim that so on, so on, so on. Now this so on, so on, so on is your original claim. And some of you ask me, what is the original claim? The original claim is a claim that you underline. Remember, you underline this. This is the original claim. So in order for you to make the conclusion, you'll be, there is sufficient evidence to support the claim that the percentage of women athletes graduating from UM is less than 67%. So this is the original claim. And in your test, you have to write it out. So you cannot just like, the claim is right here, so you just draw an arrow and say copy and paste. You will not get full points. So in your test, in your finals, make sure when you write your conclusion, if you are picking this dot, 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 dot is where you write this whole thing into it. Same thing with the one that you did just now. So that's the reason why I want you guys to underline the whole original claim, because you have to use that. This is the same as the one I'm just using. So if you have no equality and you fail to reject, then you have to use the word not. So there is not sufficient evidence to support the claim. So when you use the word not, means is you do not support the claim. Okay. If you have equality and you reject the claim, then you sufficient evidence to warrant rejection. And if you have equality and you fail to reject, that is not sufficient evidence to warrant rejection. So this is like a play on words here. The word not is negation. The word rejection is also a negation. So if you have this, you are supporting your claim. If you have this, the second one, you are not supporting your claim. This one, because of the word rejection, you are also not supporting your claim. This one, you got two, not and rejection. So like in math, two negative become positive. This will actually accept your claim. So be careful with how you do this, because it's very tricky here. So which one is which that you do? And then the last step is to answer the question. The answer the question is very easy. If you make this, your answer is yes. Check, it means it's valid. If you answer those two, it's no good, because it's you did not support your claim. So that means your claim is invalid. If you answer, if your conclusion is the last one, then it is yes. Then you answer the claim, and then your claim is true. So answering the question is very easy as long as your conclusion is correct. So you can tell that this 7 steps procedure has a domino effect. So that means if one of this is wrong, if second step is wrong, the rest of this is wrong. So just want to tell you that be careful when you guys do the hypothesis testing. It does have a domino effects here. Anyone have any questions for me? So the last thing that we need to talk about in the notes here is we don't use the word accepting, we use the word fail to reject. The reason why we don't use the word accepting is because we still have the 5% chance of getting error. So 95% confidence, you still have the 5% chance of getting error. So that's the reason why we don't use the word accept. Accept is like 100% you're accepting. So you use the word fail to reject in this case. So for those students, please do not use the word accept the null hypothesis. We fail to reject in this case due to the error that we can make in this case. Okay. So I will want you to really try to do this 8.1 homework. I will give you some examples. So make sure you guys go through this. So your homework for next week is 7.2, which is, I think you guys can do it, and 8.1, which is this one, which is a little bit tough. So I will, if you have any questions, please email it to me, because this is very important. And so homework due tonight is 7.1, 7.2, and 8.1 is next week. I also post some videos. So I would recommend you to watch the videos, and especially the video says, oh, I'm going to use a table to calculate the critical value or the p-value. I will tell you, just ignore it. Just go to this table, use your normal calculator or your T calculators to calculate your critical value and p-value, which is 10 times faster than what they did there. Okay. So, so that's it for today. I'm going to stop sharing here. Does anyone have any questions for me before you guys get going here?
I have a question for 8.1 that you just did.
Mm-hmm.
So if we run into some trouble, I like to have my homework done before the class, always. So if I have a question for 8.1, can I email, like, you know how when we do start crunching, it says email, will you be able to see it?
Oh, yeah.
Like right away?
Or
Okay.
yeah, I can see it. Or you can set a one-on-one appointment with me on Monday
Okay, okay,
if you are free on Monday.
okay. I think I'll
You
do
try to
that.
do it, and then on Monday, just send me an email. Hey David, can I have a one-on-one appointment with you on Monday at?
Okay.
Give me a time,
Okay,
like 2 to what hour? I don't know what time
sure,
you're free.
sure.
And then I will reply back with the link,
Okay,
the Zoom link, and then
Sure.
we'll do the when we do the one-on-one during that.
okay. Thank you.
So yeah, so I do want you to try it first, and then after that, set a one-on-one Zoom with me because this
Oh.
is chapter 8 is a bit tough.
Okay,
But once you get through it, then it'll be easy. Like chapter 7 looks difficult, but once you practice it, it's not too bad. Same thing with 8 because you start learning this, and then once you go through it, it'll be fine.
sure.
Thank you.